In Arcata, a chemistry professor and a group of his students are keeping their heads in the clouds to study what creates them and how pollutants may affect them. Redwood News reporter Brenner visited the lab today and has this report from Cal Poly Humboldt.
I stopped by the Analytical Physical Chemistry Lab at Cal Poly Humboldt to speak with Professor Harmon, who, along with a group of students, are creating pre-clouds and studying the conditions that lead to cloud formation.
Here we have this complicated device here that allows us to mix gases in whatever proportion we want, and it allows us to create a simulated atmosphere. We deliver those gases through all these long lines into our spectrometer right here. Inside the spectrometer, we have a tiny little reaction cell where we can monitor chemical information in real time and at the molecular scale. In the atmosphere, a particle, like a little dust particle, would enter the atmosphere, it would go aloft, and it would pick up water as it's going up into the atmosphere. And then if it takes on enough water at a certain temperature and humidity, it becomes a cloud. Additionally, that particle can pick up organics like pollutants or other small molecules, and those can get into the clouds themselves and end up raining out or depositing somewhere far away that we wouldn't expect. So there's a bunch of little tiny dust particles in there. And we flow atmosphere over the surface of those. And because our infrared beam is scattering off of the surface, we can characterize very minuscule changes to the surface of that particle. So we're really doing fundamental studies like what exact conditions do you need to nucleate a cloud just naturally? And then what we're able to do in this chamber is introduce pollutants, so we can see how that influences the cloud formation, and also how those pollutants might get trapped into the surface and travel long distances to other parts of the world that we don't expect them to be. What we have seen is that the pollutants, we call it irreversible binding, so where they are sticking to the surface and they're not evaporating off like you would expect them to. And we're seeing that they're binding to the surface for long periods of time. And for us, long periods of time means like a day or two. That's a big deal in a particle's lifetime in the atmosphere. In a day or two, a little particle that maybe was born in coastal California might make its way all the way across the US in just a day or two. Doing these studies requires a lot of organization. So I have 5 students working for me right now, and when we go to start an experiment, it takes in excess of 36 to 48 hours, and we have to run the experiment continuously. We will schedule ourselves from 7 a.m. to 7 p.m., and the students will come in. They might have a half an hour break in between classes, or they can do a couple measurements and set things up for the next student. So I couldn't do this work without my team of students. So it really is a team effort.
From the pre-clouds, because local matters, I'm Brenner for Redwood News.
Fascinating.